Okay, we're in section 33 of the notes now. And again, it's very typical. You'll be contents for you to read through and try to understand, examples for you to look through and try to understand, and then you're going to work through the exercises. All right? My name is Ron Bannon. This is the draft version of Webster Wells' Advanced Course in Algebra dating back to 1904. The PDF document that you're looking at is only available to the Prison Mathematics Project participants. However, at some point in the future, this will be published, and when it's published, certainly people can get access to that. But right now, if you need to reach out to me for any reason, that's my email address. That's B as in boy, the @ symbol, nnon.us. So let me kind of scroll through. You read through the contents, just to give you an idea. There's going to be simultaneous linear equations containing more than 2 unknowns. So like 3 unknowns, 4 unknowns, 5 unknowns. It gets tough, right? It goes through examples. We will also go through those same examples. Let's take a look. Okay, I got to erase this because it's something that I thought I erased before, but I guess I didn't. Let me erase all this stuff over here. I'm just going to work through it again. Give me 1 second. Let me erase this business over here. And I'll start anew. All right, so what I would do over here, I'm going to go through it with you. I realize Webster Wells also goes through it with you. But what I'm going to do is I'm going to try to get the equation a little more manageable. Right, I should say system of equation more manageable. And I'll do that by eliminating the x from the second equation using the first one. As I do this, though, I'm going to be calling these things rows. So row 1, row 2, row 3. So when I refer to row 1, I'm referring to 6x minus 4y minus 7z equals 17, which is an equation, but I'm still referring to it as a row. If I refer to the second equation, I'll call it row 2. The third equation, I'll call it row 3. Now to eliminate the x from the second equation, I'll use the first one. And I'm looking at 9 and 6, and the LCD there, least common multiple there is going to be 36. So I'm going to say, let's see, what am I going to say? I'm going to do minus 6. I'll write this down for you. Minus 6, row 1. And then I'm going to say plus 4, row 2. And we'll get a new equation. Whoops, I didn't put row 2 down. Let me get my eraser. Let me write this down for you. I'm doing minus 6, the row 1. That's equation number 1. It's minus 36. X. Let's see, minus 6 times minus 4 is plus 24. Y. And then, minus 6 times minus 7 is plus 42. That's Z. And let's see, minus 6 times 17 is going to be minus 60 and 42, so minus 102. And I'm going to do 4 row 2s. That's going to be 36x minus 28y minus 64 z. And then 4 times 29, that's 80, and 36, 116, right? I'm going to put a little bar down and add together. I'm eliminating. All right, this is a typical technique we did in a prior chapter, or prior section, I should say. And what do you get there? You get minus 4y. And then you're going to get, I guess it's minus 22, right? Z. And then 106 minus 116 minus 102 is 14. Now what I'm going to do, I'm going to eliminate the x in the third row by using the first row. And the way I'm going to do that is I'm going to say the LCM between 6 and 10 is 30. So I'm going to say 5 row 1. And we do minus 5 row 1 plus 3 row 3. Let's see what happens there. So minus 5 row 1, that's going to be minus 30x. Give me a second. Minus 5 times minus 4 is plus 20y minus 5 times minus 7 is plus 35, z, and minus 5 times 17 is going to be minus 50, and 35 minus 85. And then I'm going to do 3 row 3s. That's going to be 30x minus 15y minus 9z equals 3 times 23 is 69, right? Little bar here. And let's do it. And what do you get? 5y. That would be 26z. And let's see, minus 85 and 69. Right? That's going to be what? Minus 16, right? Okay. So I have 2 equations now. This equation here and this equation here. And really what I did a system with 3 unknowns in it and 3 equations. And I now have it down to 2 equations with 2 unknowns. And that's written over here for you. And what I'm going to do over here, I'm going to use elimination to find out what the x and the z now. And I'm looking at it, and I'm going to say, 5 row 1 and 4 row 2. Let's see what happens. This is not as bad as it looks. Minus 20y. Let's see, that would be minus 110, right? And 5 times 14 is 50, and 20, 70. Let's see, that would be 20y. 4 times 26 is 80, and 24, 104. And 4 times minus 16 is minus 64. Little line here. And I'll kind of add it together. And what do you get? Well, let's see, minus 6a. And 70 minus 64 is 6. So I'm going to say z is minus 1. Okay? By the way, I could be wrong. What I'm doing now, I'm going to work my way backwards. And I'm looking around for an equation that has a z in it and another unknown. And I'm going to use this one right over here. And what would you get? You would get minus 4y. And if z is minus 1, you get plus 22. And that would equal 14. What do you get? Minus 4y. If I took 22 from both sides, I would get minus 8. If you divide both sides by minus 4, you get y is 2. Right, again, I think this is correct. And basing this on the truth, this would lead to this. And now I want to go backwards and find another equation that has a z in it, a y in it, and the letter x in it. And I'm going to use this one over here. Let's go for it. 6x. Now, what's minus 4y? That would be minus 8, right? And minus 7z would be plus 7 and 17. Well, that would be 6x minus 1 equals 17. So this would lead to, I'm just walking forward on it. I know it's jamming it in there. 6x equals 18, x is 3. Okay, I could be dead wrong, by the way. And I'll tell you why. I don't know if I'm right. So I'm going to point out, if I'm right, this should check beautifully in the system. I'm going to get my eraser out and just erase the artifacts over here. And this is the original problem. And I want to see if it makes sense. Someone says, what do you mean it makes sense? Does x equal 3, y equal 2, z equals minus 1? I don't know. I'll put it down. It's going to be the check. And the check should be quite easy if the numbers are easy. So I believe x is what? 3, 18, 27, and 30. That's not so bad, right? I believe the y is 2. Minus 8. Give me a second. Minus 14. And again, I believe y is 2. Minus 10. I believe z is minus 1. plus 7, plus 16, just plugging it in, plus 3. Well, let's see if it gives us what's advertised. This would be 17, just doing the arithmetic. This would be 29, I'm just doing simple arithmetic. And this would be 23. 17 is advertised, 29 is advertised, 23 is advertised. So x equals 3, y equals 2, z equals 1. If you look over here, they're going to tell you that too. Again, if you're looking in this, y is 2, z is minus 1, and x is 3. They do go on to say there's many ways to solve the system equations, all right? I'm just hopeful that you'll see some patterns to these problems over here, and that the elimination pattern is probably the best way forward. Not always, but you do an elimination, then what we do, we back substitute it. We found one of the variables, we try to use that to find the other variables. All right, the next one is a killer, all right? So what I'm going to claim over here, looking at it, you can play around with it, and I would say it's probably the best thing you can do is just play around with it. But there's now 4 equations, 4 unknowns. And again, we have other techniques for doing it, but right now, let's just play around with it. And certainly when I'm talking about this over here, I want to emphasize again, row 1, row 2, row 3, row 4. I'm just going to add them all together. And the reason for that is, I believe if I do that, maybe there'll be a simple pattern to the problem, just by adding them all together. So let me take a look at it. And I'm really I have to be careful here. So if you add it all together, I'm going to do the numbers first. What would you get? 6 plus 7 plus 8 plus 9. I'm adding them all together. Now let me just do this over here. 1, 2, 3. I'll erase this later, by the way. I'm going to say there's 3 u's if I add it all together. 1, 2, 3. There's 3 x's if I add it all together. Let's do the y's. 1, 2, 3. 3 y's if I add it all together. This may lead nowhere. 3 z's if I add it all together. Again, this you might say this is going nowhere. It may go nowhere. I'm not saying it doesn't. So what do you get? You get 3u plus 3x plus 3y plus 3z equals, let's take a look at it. 6 and 7, that's what? 13. And 8 plus 9 is 17. 13 and 17 is going to be 30, right? Now I'm going to divide everything by 3, both sides. What do you get? U plus x plus y plus z equals 10. All right, I'm going to erase the nonsense over here. It's just my bookkeeping. And I'm wondering if that helped me. I think it does. And what I'm going to go through is I'm going to look at one row at a time. And I'm going to look at row number 1. And if you took row number 1, let's see if that does help me. And if I did that, what would I get if I subtract row 1 from this thing? The u, x, y, z. What would I get? Well, the u, x, y would disappear, right? So let me repeat this again. I'm going to take this from this. This is an elimination process. Well, the u would disappear, the x would disappear, the y would disappear. Right? So what would you be left off with? Well, you're left off with z. And again, take 6 from 10, z is 4. We'll check it later, okay? I could make a mistake. So I'm going to say that's done. Now, when I say it's done, I'm not saying it's right. I'm just saying I'm done with it. Now, let's look at the second row. Now, I'm going to take this second row from the u plus x plus y plus z equals 10. See what we get. So the x would disappear, the y would disappear, the z would disappear. I'd be left with u. And 7 from 10 is 3. I'm not saying this is right, by the way. I'm just saying my pattern is living up to this. Let's take that third row. Let's take the third row from the u plus x plus y plus z equals 10. What would you get? Well, the y, z, u would disappear. Y, z, u would disappear. You're left with x now. And 8 from 10 is 2. We're going to check it in the end, by the way. Let's go to the last one. Eraser out. This is the last guy right here. And I'm going to take that from the u plus x plus y plus z equals 10. Well, the u disappears, right? The z disappears. And the x disappears. I'm left with y. And 9 from 10 is 1. Right, so I'm going to say this looks like a, they look at nice numbers too, right? Let's check it. All right, I know it's tough, but I want to check it. So I believe u is 3. Let's do the first row. This is the check. I believe u is 1. I'm sorry, 3. I believe the x is 2. And I believe the y is 1. And they said 6. That is good. Let's do the next one. X is 2. Y is 1. And z is 4. What would you get there? 4, 5, 7. This worked beautifully too. Let's do the next row. That's the third row. What's y? Y is 1. What's z? 4. What's u? 3. What do you get there? 8. It's remarkable. It's working out beautifully. Let's do the last one, which is z. What's z? Is 4. And then wait, we got u is 3. And then what do you get? X is 2, right? So what do you get there? 9. Works beautifully. They all work beautifully. All right, now someone says that's pure luck, or you remembered what you saw before. Maybe, but here's the problem. You can do this in a variety of ways. One thing I want to point out to you, if you're thinking about it, you might want to put this in a better order. And what I mean by that is, thinking about it, I would say, like, if I were doing this thing over here, and I'm going to just give you, like, sort of like a heads up. If I were to look at this, I'd say u plus x plus y equals 6. The next one would be x plus y plus z equals 7. I think you notice I'm lining things up now. And what's the next one going to be? Y plus z, and this would be a u over here. I'll put a plus sign there, equals 8. And the next one's going to be what? There's a z, there's a u, and there's an x. Now someone says, that looks really crazy to write that down. But later on, when you study mathematics, you're going to be writing this way. 1, 1, 1, 0. You're going to put a line here, a 6. And then you're going to put down 0, 1, 1, 1, 7. Next row would be 1, 0, 1, 1, 8. The next row would be 1, 1, 0, 1, 9. All right, let me just remind you what we're doing over here. We're actually simplifying the system by doing that. Now, if you study math further, this was called an augmented matrix. They're actually a lot easier to deal with than what we just did over there. And really what you're trying to do is you're trying to boil it down to a really simple statement. So this one over here, and again, don't worry about if you can't follow what I'm stating over here. If you saw this one over here, I'm going to say the first column is the u, the second column is the x, the third column is the y, and the last column is the z. So if you were to write down the final solution over here, you'd see something like this. And I'll tell you what this means in a second. Well, what's u? U is 3. I'll read this to you later. What's the x is 2. What's the y? The y is 1. And what's the z? The z is 4. All right? Whoops, I'm sorry. I said something. That's not true. I said 4, right? So let me repeat this, what we got over here. These are the u's. These are the x's. Y, z, constant. So if you read the first row, you'd have to know it's a u, x, y, z. Second row, U, X, Y, Z. Third row, U, X, Y, Z. Fourth row, U, X, Y, Z. This line over there is an equality. If you're looking at this thing over here, what does it say? U is 3. There's no X, Y, and Z in it. This says X is 2. Let's see. No U, no X, Y is 1. What's this one over here? That's going to be Z is 4. All right? Now, granted, I realize for some students saying, I don't know how to go from that to that. It's actually a lot easier than what we're doing. All right? We're not there yet, though. So here's the deal. Play around with the system. Someone says, this is the only way to do it. It is not the only way to do it. There are many ways to do it. For example, you may say, I want to try a different approach to it. For example, you could take the first row and subtract away the second row, and you will get a simpler statement, all right? Now, if you did that, I'm not suggesting you're going to do that, though, but if you were going to do that, if you took the first row, subtract the second row, what do you get? You would get U, whoops, sorry about that. You would get U, and again, I'm taking first row, subtract away the second row, you would get U, the X would disappear, the Y disappears, minus Z equals, well, 6 minus 7 would be minus 1, all right? And then someone says, what are you going to do now? Well, maybe you could take this row and subtract this row. You get the idea? And what would you get? Well, let's take a look at it. The Z would disappear, the U would disappear, you would get Y minus X. Whoops, I did it again. You would get Y minus X equals 8 minus 9 is minus 1. And you could play around with this, all day long to get to, simpler equations. Maybe it's working out, maybe it's not working out. You could take this row and this row. You could subtract them too. Things disappear, by the way. What would you get? You would get X. If I'm subtracting Y, just be X minus U equals minus 1. I think you're seeing something here, though. And what are you seeing? You're seeing simpler equations that might be able to help you out with this. And you keep going through this, all right? One at a time, pairwise, whatever. You get through it. I like this, though. This worked out pretty nicely, all right? Are there other ways to do it? Yep. Augmented Matrix worked out nicely, and they really do. Simple row operations is what you get to. Here's the deal, though. We checked it. We know we got the right answer. Are the answers simple? Of course they are. Are there tricks? Yeah. The best trick you have is try. It's the best trick you got, including if you're taking a dead end, take a dead end. When you take a dead end, at least back out when you know that, all right? So what I did over here, I did it a different way over here, and that's okay. So someone says, what did you do over here? You may want to follow my row operations. They're written over here. I'll outline that for row 1 minus row 3, given to row 3, row 1 minus row 4, give it to row 4, so forth and so on. And if you did that, it's not that bad to do, but I did do that. I eventually get down to this 12. You see that? 3Z is 12. You may want to look at those operations. And let me tell you how I back out of it after doing that. This would be Z is 4. Then I would take this. I'd plug it into the row above it. What do you get? Y plus, well, if Z is 4, I'd get 8 equals 9. So now I know Y is 1. Then I'd go back up here. What would I get? X plus, well, I think Y is 1, and Z is 4. And what do you get over there? That equals 7. Let's see, that means X equals 2, right? And then what do? You go back up again to this row over here, and what do you got? You got U. I don't know what that is yet. What's X? X, I believe, is 2. And then you got Y. What do I believe Y is? Y is 1. And that is equals 6, so U would be equal to 3. All right, let me just put a circle around that. I want to point out these answers are listed for you, at least I hope they are. Z is 4, Y is 1, X is 2, and U is 3. Are they the same answer we got before? Z is 4, Y is 1, X is 2, and U is 3. No different at all. But again, it's a variance. Someone says, well, why did you do it this way and not the other way? I don't know. Maybe I couldn't remember what I did last time. I take a different road. I can say all roads lead to the truth if you're following the road correctly. And it really does. Now, I got to be honest with you, though. It's tricky. It's really, really tricky. And for a lot of people, it is super, super, super frustrating, all right? But I do claim this over here, Wells starts out pretty simple. I mean, it's like the first problem. Generally speaking, these will be pretty easy. 3 equations are unknown. What would I recommend? Get rid of an x, then you'll have an equation with 2 unknowns in it. Elimination works out beautifully, all right? Answers are provided, but there's no work. Answers are provided, but there's no work. If you go to this one over here, again, what I would be doing is I'd be getting rid of the fraction right away, and then I have 3 equations, 3 unknowns. You can solve that just like you solved number 1. It may look impossible, but it's not, all right? So the variables are x, y, and z, all right, x, y, and z. 3 equations, 3 unknowns. Over here, more difficult, no doubt about it, all right? The variables are x, y, and z. What makes it more difficult? Now the coefficients are not numbers, but they're letters, A, B, and C. There's many ways to do this one over here. But I got to be honest with you. This one is going to be tough. Whoops, give me just 1 second. Now, when I say it's tough for me too. I got to look around. But there's one thing I'm assured of. They're not asking me something I can't do. All right? So it's an interesting problem. You get through it. You'll get through it. All right? This one over here, I'm not going to say that tricky. You know, it's like X, Y, and Z in it. I would probably try to get rid of the fraction over there and then proceed forward as prior. All right? This one over here, you know, maybe something that, you know, that last system equation we did, you know, maybe you can do something else with that. Maybe you'll find some easy patterns to that. Do they have to be the same thing that I'm doing or somebody else is doing? No. There's an infinite number of patterns, including guessing at what U, X, Y, and Z are. You could do that. You know, certainly at this level of the game, they're really going to be really nice numbers. But, you know, give it a shot. Give it a shot. And they're tough, by the way. This one over here, again, you might find this very difficult, but they're doable. I want to assure you that. Also, we give you answers. These answers look tough, though. There's no doubt about it. They look like tough answers. 7 looks tough, but probably not that tough. Not that bad. 8 looks tough, but probably not that tough. 9's got those, like the A, B's, and C in it. They're indicating some numbers. And the X, Y, and Z are the variables. They want to solve for that. And it's tough. I'm not saying it's not tough, but give it a shot, all right? The harder you work in this, the easier these are going to become for you. 10 also looks like a tough one. It doesn't look like a tough answer. Here's the magic, though. After you struggle, you start to realize, are machines capable of doing this? And yeah, and someone says, why is a machine capable of doing this? The people that are coding these machines know how to do those problems by hand. Otherwise, they couldn't have coded it. There's no way they could have coded that. But anyway, we're talking about Sage. What's Sage? A computer algebra system. It's free. What I mean by that, it's open source software. Go to this website. You can download the application or use the interactive web-based application and try to do some of this coding here. All right, you might just type that in there and see what it comes up with. All right, not bad to do, not bad to try. The deal about this one over here, I do realize you might have some questions, including saying, hey, you made an error on problem yada, yada, yada. Let me know that, and you'll get credit. I'll put your name down in the book. All right, I know it's a tough section. Do your best. Thank you so much for your attention.